Hello, welcome to Listening to the Wind, the International Windship Association's regular interview series. And we, as you know, we're focusing on the pioneers in the sector, and we certainly have one of the pioneers sitting with me today from bound4blue, and that's David Ferrer Desclaux. I hope I got your name right there, David.
It's pretty much well, yeah.
Well, thank you for joining us, taking time out of your very busy schedule. From what
You're welcome.
And I'm just going to quickly introduce David, and then I'll hand over the reins for a short presentation on the bound4blue activities. So David is co-founder and CTO at bound4blue, in charge of the technical development of the solutions and products, as well as leading the commercialization action. David holds an MSc in aerospace engineering and another one in project management. So you're a very well qualified person to be talking about this. His past experience is in startup management, scaling up of industrial companies. David was selected by MIT Technology Review as one of Europe's innovators under 35 and awarded as Visionary of the Year in 2018. So I think we're in very safe hands. So David, yeah, welcome. And I'm going to hand the reins over to you, and I'll see you on the other side of your presentation.
Thank you very much. I'm going to share my screen. And confirm me you're seeing everything.
Yep, all looking good. Just need to go to the
full screen.
Full screen. Fantastic.
Okay, so well, thank you for the introduction, Gavin, and thank you everyone who will be looking to this presentation. I'm going to try to give you a short glimpse on bound4blue, who we are, what are we doing, and where we are now. So bound4blue's mission is to deliver automated wind-assisted propulsion systems as a turnkey solution to decrease fuel-related costs and pollutant emissions. And with this in mind, we, the three founders of the company, decided to start the company back in 2014. And now we are proud to say that we will end 2021 with 3 offices worldwide, more than 20 people in the team, with the support from the European Union, EIT Climate Kick, the European Investment Fund, CDTI, and several other private investors, having been awarded, between others, by Forbes and MIT, having developed 2 different technologies, the wing sail and the e-sail, and with e-sail installations on board 2 vessels. So let's start by understanding a little bit the value proposition that wind-assisted propulsion system has. These systems generate propelling force from the available wind, which makes it possible to reduce the load on the main engine, which has 2 positive consequences. The first one is that fuel consumption is reduced, and with it, the fuel-related bill from any kind of fuel, from standard fuels like heavy fuel oil or MGO or whatever it is, but also from alternative fuels like biofuels, ammonia, or any other future fuel that may come. The second one is that double-digit savings in pollutant emissions are obtained, which is key to meet regulations such as EEDI, EXI, CII, etc., etc. So bound4blue has developed 2 different wind-assisted propulsion technologies: the e-sail, based on suction as active boundary layer control system, which results in the cheapest and most efficient solution, and the wing sail, a collapsible sail when foldability is a must for the customer. Focusing on our last unveiled product, the e-sail, the best way to understand its advantages is by understanding the aerodynamic principles behind it. So the amount of lift that an airfoil or an aerodynamic body can generate is proportional to the angle of attack, which is the angle between the sail and the wing. Higher angle of attack means higher lift, up to a point where when the airflow detaches, which is what you see in point number 3 in the graph, and at that precise moment, lift is suddenly lost. The idea behind suction is to control and avoid the detachment of the airflow to increase the achievable lift by reaching higher angle of attack and using more efficient airfoil shapes. So the e-sail has a thicker profile, as you can see on the right, and if suction is off, it is fully detached with no production of lift. And in fact, this is a safety mechanism, as any failure would lead to a switch off of the fan or switch off of the suction, and immediately this takes the sail to a safe status. However, as soon as suction is on, the airflow reattaches, already generating lift, and then you can increase angle of attack to reach extremely high lift capabilities. The key here is that the e-sail can produce much higher lift compared to a passive airfoil, and as a consequence, e-sails can be 5 to 6 times smaller with all the associated advantages. So the e-sail somehow combines the advantages of hard sails and rotors, avoiding its disadvantages, so resulting in a technology that has smaller size thanks to the excellent aerodynamic efficiency, so offering low weight, low impact on stability, on visibility, lights, deck occupation, aircraft, etc., and at the same time, it has excellent capacity to sail upwind due to the low drag, low power consumption, and mechanical simplicity. No constant rotation, no big inertial loads, etc., etc. So it is, in the end, a system that offers high savings with low OPEX and CAPEX, resulting in an unbeatable payback. The e-sail has a very simple structure composed by a pedestal with a standard bolted flange connection to the vessel deck, a tubular structure generating the aerodynamic shape and acting as the main structure, a flap connected to the main structure to generate the variable geometry of the sail, and a suction area specifically designed to avoid flow detachment. The three-man operation is done by 3 electric actuators, orientation to the wind by means of a slew bearing and an electric motor, positioning of the flap by means of an electric motor again, and suction by means of an electric axial fan. And finally, all the operation is fully automatic, thanks to our autonomous control system, which removes any kind of workload or training to the crew. The main target vessels that will profit from our e-sail include, between others, fishing vessels, general cargo vessels, ro-ro ferries, and cruise vessels, tankers, bulkers, and gas carriers. And to better serve this market, adjusting to the large variability in vessel size, vessel types, etc., we have developed an e-sail portfolio of 3 different models of increasing size with variable height and automatic control system. And additionally, they can include a tilting system and X-rating as an option. I would like to share some example figures on what can be achieved thanks to our e-sail. The first example is a general cargo vessel with 2 e-sails of 17 meters height, trading between Rotterdam and Skagen. This is assumed to be a round trip, so both directions in sailing. And based on historical wind data from 2010 to 2018, the average savings would be of almost 1 ton per day, per sailing day. The second example is an MR tanker vessel with 3 sails of 26 meters height, trading between Rotterdam and New York. Again, based on historical wind data from 2010 to 2018, the average savings would be of almost 4 tons per day. Assuming, for example, 220 sailing days per year, it results in savings of more than 800 tons of fuel per year and more than 2,500 tons of CO2. And as a last example is a Cape-sized bulker with 8 tiltable e-sails of 36 meters height, trading between Tubarão and Qingdao. And in this case, the average savings would be of more than 12 tons per day. And again, assuming 220 sailing days per year and a fuel cost, for example, of $600 per ton, fuel bill would be reduced by more than $1.5 million per year. So our goal now is to perform full-scale installations of our technology on the identified market-relevant types of vessels. The first one, which has been co-founded by the European Union, was done last May on a longliner fishing vessel, onto which we installed a Model 1 e-sail of 12 meters, so the smallest one. That is now performing sea trials in the Pacific Ocean. The second one, also co-founded by the European Union, will be done on a 62 meters length general cargo vessel, onto which we will install a Model 1 e-sail of 17 meters height with a tilting option. The transformation approval from DNV has already been granted, and the installation will be completed by early November. Here you can see some pictures of the e-sail being manufactured, and the vessel is in fact entering the shipyard tomorrow. So everything is getting ready. We are now also working on additional installation projects to cover the market relevant types of vessels that we have identified. And these installations include another general cargo vessel with 2 e-sails of 17 meters, a ro-ro vessel with 3 sails of 22 meters height, a tanker vessel with 3 sails of 26 meters, and a bulker with 4 tiltable sails of 26 meters. And I'm sorry I cannot give you much more details on these 4 projects right now as they are confidential, but trust me that updates will be released soon, even very soon. Finally, I would like to share what are the steps that a ship owner will follow to install our technology on board their vessels. So the first one is to evaluate the suitability for wind assisted of the vessel or the fleet. So to do so, we offer a free of charge dedicated preliminary business case. So the message is, if you are curious, just contact us with no compromise and get informed. The second step is to prepare your vessel for wind assist. This includes engineering work for the selection of the optimal sails configuration, so how many sails, where they are located, etc., and for the transformation design and approval, and then shipyard work to be done afloat to prepare the vessel for the installations of the sails, where the main task is basically to install the deck foundations onto which the sails will be installed. And this is usually done and is recommended to be done during one of the scheduled visits of the vessel to the shipyard. And then the final step is to install the sails on your vessel. So this can be done at shipyard right after the foundation's installation is done, or during any other port call at any later time, as the operation takes less than a day. And this can lead to different strategies. You can install all your e-sails at once, or, for example, you could do a progressive installation of e-sails to increasingly adapt to the CII, while dividing the CapEx investment along a longer period of time. However, in line with this last point, we're putting in place with some financial partners hardware as a service financial instrument in which the CapEx will be funded by a third party, which then recovers the initial investment by sharing the yearly savings with the ship owner. So the message here for the ship owner is that you can forget about CapEx. And that's all on this brief introduction. Now I look forward for your questions, Gavin.
Fantastic. Thank you very much, David. And such a good presentation. You've answered quite a few of my questions already. But it sounds, I mean, the progress that you've made over the last 12 to 18 months is fantastic. So first of all, I just want to say congratulations. And seeing that first installation on the fishing vessel, that was great earlier this year. So yeah, that's brilliant. First question though that I've got for you is that you mentioned in one of your first slides about the wing sail development, and I remember seeing the retractable wing sail that you developed, which is a really interesting project. And now you've moved with a second product, the e-sail. And just wondering, what was the process in developing that second product?
Yeah, one of the obsessions from the very beginning at bound4blue has been to be in constant contact with all the stakeholders that we can from the industry, to receive constant feedback from them on the requirements, the needs, the perceptions, even or the fears, whatever they had. And with all this information that we got, we identified that if we want to offer or make available wind assist to the largest amount of vessels possible, we required to have more than one system. So that's why we developed two. So some vessels, mainly due to the port operation, they require a collapsible system, because a fixed system or even a tiltable one, for example, there are some vessels that the tiltable one will occupy part of the deck and is not acceptable, does not fit their needs. So those would be served with a wing sail. However, some other vessels, they do not require that collapsibility. And in the end, collapsibility means higher cost and more complexity. So if you can avoid that, let's do that. And to be sure that you don't need this collapsibility, you have basically, if you're able to keep air draft at a controlled height, you don't need collapsibility anymore in several other vessels. So to do so, you need a system that has high lift. Because high lift means smaller size, so you can control the size of the sail. And this high lift, well, we started with this idea on exploring which are the options of developing high lift systems. And basically there are two systems, flat end rotors and suction sails. We did a detailed analysis on both options, and what we concluded is that suction sails were the best option. However, the main challenge here is that while there is plenty of information published on flat end rotors, there is very little in suction sails. So the work has been limited to Cousteau teams, so Malabar and Charrier, and there's not a lot of information. So this requires, for any company willing to do having this technology, it requires a strong R&D effort and time effort to understand the aerodynamics, the performances. Basically, to develop that technology takes a lot of time. But once this know-how is acquired, it really pays off the effort, because the system it's more efficient.
And I think, you know, for all SMEs that are coming into this zone, that R&D period, that knowledge acquisition period as well, it's a challenge. It's a challenge to get over that hump. So I'm delighted to see you coming out of the other side of that as well, which is great with the product. You mentioned in a couple of your slides, you know, for example, the incremental installation process, you know, being able to comply with the various ratcheting of CII, for example. How do you actually see CII and you know, the EEXI introduction from IMO? How do you see this actually driving the market?
Well, I think that it is kind of I think from my point of view is that it is kind of obvious that the industry of wind propulsion or the success of wind propulsion cannot rely only on fuel costs due to its variability. We all know what happened back in the 80s. Fuel costs went up, Jamda sails were developed. I think 18 units were installed. Then fuel costs went down. The industry disappeared because no one cared about pollution. And that cannot happen again. So what I think is that these measures, basically linked to the emissions, for me, they are the key factor for the market, as their implementation is what makes wind propulsion a viable solution, but especially a sustainable solution in time. So we as bound4blue, and I'm pretty sure that all the suppliers of wind propulsion, we are very happy and welcome that these measures appear here, leaving apart all the part that as a citizen, I'm happy that we're fighting climate change. So
no, that's a fair comment. I mean, I think, you know, one of the issues is going to be along the lines of, for example, with CII for non-compliant vessels, will there be the market pressure to improve those ratings, or will there need to be sort of teeth within those regulations to actually push that bottom end going up? But I would assume that you're looking at the sort of first movers in the market just at the moment. You were talking about the various different segments. Which of those segments do you think is going to see the biggest growth in wind propulsion uptake?
That's a good question. I mean, I think it's kind of depending a little bit on what's the driver for each ship owner. For example, bulk vessels, they are usually very old vessels, so I guess that CII is going to be pushing a lot on them. So that can be a sector with a lot of interest in wind propulsion. However, I think that all the industry is affected at the same level. So I think all markets I think they will be growing pretty fast as soon as the technology is it's seen as safe, validated, and let's say like a real product, not a prototype. That may be a little bit the vision right now.
No, absolutely, and actually you had quite a few logos in I think the second to last slide of companies that are sort of within your network or your framework. How are you actually working with them and collaborating with them?
Yeah, well, as you can imagine, a single company like bound4blue, we cannot do the whole process of installation of wind propulsion. So basically, we are a supplier of a technology. So our role is to design and develop this technology and supply this technology. And we also focus on, let's say, the selection of the optimal configurations. How many sails should you put on your vessels, on the performances, how to operate them, etc., etc. But then any installation project is a partnership, is a project with several partners and stakeholders which are required. So just for example, you need to collaborate with naval engineering firms, with Glass Society, with FLAG to do all this design approval. You need a shipyard, of course, bound4blue is not a shipyard, you need a shipyard to the integrations. And that would be like external partners to bound4blue. Then we have our supply chain. Of course, we don't manufacture those sails. We have companies and partners that we collaborate with, which are basically tier 1 companies with an extensive expertise in manufacturing both naval and offshore wind products, which we think is the best solution, because these are companies that manufacture with top quality for the wind industry, for example, and they are used to go from a prototype or single unit to large-scale production, implementing economies of scale, lowering production times, production costs. So we see those manufacturers as our partners, because they are gonna help us to go from these single units to tens and hundreds of units, and that's something that they do. And the good thing is that the good thing is that in Spain we have quite a powerful industry in wind, in offshore wind turbines, etc. There's a lot of manufacturers with a long experience in this, and our e-sail, for example, is very similar to the tower of a wind turbine. So we're profiting of this expertise to have better quality products and with more safety.
No, that's excellent. And I think, you know, quite often when I talk with SMEs, you know, the valley of death of getting your product into market is a real challenge, and I think we all know that. But actually, sometimes what is neglected is the challenge of that scaling of production. After you've made your first maybe 10 bespoke installations, then you're actually ratcheting up to 20, 50, 100 units. And that's a massive challenge for small companies to expand there as well. So I think from what I can see, you're surrounding yourself with companies that have that expertise.
Yeah, and it's something that has to be taken into account from the beginning, because if you're designing something that cannot be manufactured as mass production, you will have to redo your whole design. Because maybe you're designing something as a single unit, and then it's impossible to manufacture 20 in line. Or it's going to be as long as manufacturing 20 one after the other. So you really have to take that into account from the early beginning of your design.
Yeah, no, I can see that very clearly, and very clearly explained as well. And so I'm going to get down to the bottom line here. You just ended another funding round, securing about 4-5 million.
5 million.
Yeah. So other than the 2 or 3 Ferraris that you're going to buy, what are you that would be nice. Now, what are you actually going to invest that money into?
Exactly. As you saw in the presentation, the 2 installations that we are doing now in 2021 are of Model 1, so the smallest model up to 17 meters. The other installations that we're planning that we're starting to work right now, they require the Model 2. So most of the funding is dedicated to the scale up of the technology, so going to the next level. So designing them. In fact, this manufacturing design is almost ready for the Model 2. And after that, it's going to be dedicated to manufacture several units and complement those piloting projects. So that's the main focus. Then, of course, there are other things like increasing the team, increasing our marketing and communications effort, commercialization effort, that, as you said, we've been kind of low profile for the last time while we were developing the eSail. Now things have changed, everything is public, so now we're going to increase our communication.
Right, interesting. And I'm just going to ask you one more sort of general sort of discussion point. You know, I've been in this space for quite a few years. You know, seen some changes in the industry, and I'm not sure exactly when did you come into the industry? bound4blue started what, 3-4 years ago?
2014. The company was founded. Yeah.
Right. Okay. And yourself. So that coming in over the last six to 7 years, although the last 18 months has been a little bit of a strange period. But what changes have you seen around the shipping industry and how it's interacting with wind propulsion?
I think that the making a long answer kind of short, I think that what has most changed is the mindset. From a perception of questioning whether wind propulsion would ever happen, or if just a crazy idea of some people, to nowadays where I think that everyone assumes that wind propulsion is a reality and it's gonna remain as a solution, and it's just a matter of when will it reach the adoption level in the technology adoption life cycle, which fits with where I as a ship owner feel comfortable with. So we are now at the early adopters, but I see that the laggards think that sooner or later they will install wind assistance. So it's a radical change in the mindset, considering this as a real option.
And what do you think's triggered that?
A lot of effort from all the from all the industry. I think it's
gray hairs.
Yeah, I think that as you said, it's been like 6-7 years of several companies, not only bound4blue, there are other companies doing that, reaching new milestones. So it started with a PowerPoint, then suddenly there's a prototype, then suddenly someone installs one unit, then there is a publication of information and certified by LR. So I think it's a step-by-step work. I wouldn't say that there's one single thing that made that mindset change, but it's step-by-step.
No, I think certainly from my point of view, there has been a real perception shift, especially in the last couple of years. And I think, as you say rightly, having units being demonstrated, having vessels starting to come into the market, technologies coming into the market, breeds more innovation, more companies pushing their products forward as well. So I think there's some healthy competition out there for you as well.
It is. Always good. I always say, because many people say, what's your competition, etc. Well, I always say that right now there is not a competition. Any success from any other partner, it's a success because it's helping to take out those barriers. Yeah. There's also a risk. Any big failure of any partner is going to be a failure for the whole industry. But usually what I'm seeing are successes. So I'm happy that everyone succeeds, and in the near future we will compete. But right now I'm happy with any success.
I think there's quite a bit of space out there at the moment. Absolutely. Okay, now I'm going to come off the kind of discussion points, and I'm going to hit you with a few minutes of sort of quick fire questions. So if you can give me a sentence answer, I mean, you can go with the yes and no, or just a grunt. A single sentence would be nice. So I'm going to start off with, how did you personally get into the wind industry?
Maybe also a good question is, why did I get into shipping, being an aerospace engineer? Well, I think that all engineers, we have the need of finding problems, not creating them, finding them and try to solve them. And climate change in general and blue light emissions in shipping, it's in particular, I think it's quite a big problem and a very interesting challenge to try to solve. Of course, to start a company not only requires the engineering pleasure of solving a problem, but also it has to be business-wise. So we had that idea of putting this engineering idea of why not putting sails on vessels, like a crazy idea of an engineer. But we decided to start with the company back in 2014 when we saw that these new regulations to limit shipping emissions were starting to pop up, and we saw that that was the moment to start because we knew it would require some time to develop. So that was the moment to start bound4blue.
So a double challenge.
Exactly.
Or possibly even a triple challenge. You know, coming into shipping, then coming into wind propulsion, and setting up the company.
And
I love it.
Exactly.
I love it. I love it. And okay, so going back, you're back in 2014. What would you say to yourself as a piece of advice back then?
What I would say is, and that's also in line with what I said, that from the beginning we tried to have all the feedback from the stakeholders. What I would say is, don't only focus on the technical development of your technology, which is usually a typical mistake from engineers and scientists, that we focus on aerodynamics, performances, super lightweight materials, etc., and you forget about the rest. So remember that below your technology there is a vessel that shall comply with regulations, that shall be maintained. It has to keep on doing its regular operations with a crew of people who has to understand what they are doing, and that it has to be paid by someone. So carbon fiber is great, but it's very expensive. Is it worth it? So think about all the other questions.
Okay, and on that, what is the most frequently asked question? Frequently asked question.
It's basically what savings I can achieve with your technology on my vessel, and the answer is it depends. What's your vessel? What's your routing, etc. So because it really requires a case by case analysis. If you have a vessel and you don't use it, or you use it where there's no wind, you're not using wind propulsion. So that's why basically we offer a free of charge preliminary business case for anyone who is interested, just to see if it's feasible or viable for them to install that technology.
And I know, I mean, that word depends. It is a challenge because a lot of people want to know it on a motor vessel operational profile without any changes to how they do business or the route they're using, etc. So I take your depends as an okay answer. What's the most difficult issue you and your team have had to deal with?
I would say that doing our first installation, the one on the fishing vessel in Panama, so at the other side of the world, and during COVID-19 strike, has been quite challenging and an excellent learning process.
So you chose a really easy first installation.
Yeah, we did.
At perfect time. Yeah.
Yeah, it's been delayed due to COVID-19, so it's been tough, but it's a good experience, a good learning exercise.
I can imagine a steep learning curve on that.
Yeah.
Absolutely. Okay, couple of quick ones. Have you done a life cycle analysis or an environmental sort of carbon footprint of the rigs that you've done?
Yes, we did it together with EIT Climate Kick. We were in a program with them. We got funding, and one of the tasks to be done was that. So we used it. We did it using their climate impact forecast tool. And well, just as an example, for the MR tanker case I showed in the presentation, the CO2 footprint is recovered in less than 3 months of operation of the vessel.
That's very good. That's very good. And I know a lot of investors are increasingly asking for this kind of aspect
analysis
considered. So that's great. What is the most common misconception about what you've developed or about wind propulsion in general?
I'm laughing because I'm pretty sure that you are having kind of the same one. The most common misconception is there's some people who thinks that our e-sail produces electrical power, like if it was a wind turbine, instead of propulsion force like a sail would do. And I'm trying to fine to reword my explanation because I still get that misconception, and I think I'm going to use part of your wording because I've seen some of your presentations and you make some focus on that. So I'm pretty sure that you're getting kind of the same misconception sometimes.
I do. I also get the misconception that the wind pushes the sail as well, as opposed to creating that suction and pressure differential. So yeah, that's a challenging one. But you know, again, we have to adapt to the perceptions and the markets that we're talking to. So my last question, and a key one for a lot of people, is last key one is, are you recruiting at the moment?
Yes, well, I don't know if exactly now there is an open position, but along this year we have increased the team by 35 to 40%, and there's still we're gonna increase the team in what's missing of the year and next year. So if someone is interested, just follow us on LinkedIn, where we post our job offers, and if someone is interested in any of them, just inscribe to it.
It's exciting times. And just I missed one here, which I am interested in, which is, you know, the feedback from the performance on the fishing vessel. Can you share anything at the moment?
Well, the vessel has been sailing for 4 months right now. We are collecting operational data from with the sailing operation and the sail out of operation, but we still need, from the data we got, we still need much more time of sea trials before obtaining any figure, any KPI that we can say 10%. Basically, because what we're seeing is that the fishing vessel is maneuvering a lot. So it's a vessel, is not like a general vessel that goes one way with at a certain speed laden, and then it comes back at another speed at full charge. But the fishing vessel is all the time accelerating, braking down, going backwards, turning, etc. So the amount of data and the dispersion of data is very large. So it's going to take a lot of time. So before getting a KPI, I think it's going to take at least 4 to 5 more months. So I hope that next year we'll be able to share this KPI. What I can say now is that sail is operating as expected, and the crew is happy. The vessel they didn't have any issue with the ship. No negative impact in their day-to-day operations. So right now everything is going smooth and fine. We'll see the savings in a few months.
No, that's fantastic, and obviously, you know, the fishing fleet out there is a huge fleet, which is often underestimated on just how large that fleet is. So some really interesting potentialities there as well. So okay, I'm gonna stop the interrogation a little bit and give the reins over to you for the last minute. So this is an opportunity for you to give the audience your kind of 1 minute summary or your takeaway, whatever you would like them to remember from what we've been talking about today.
Okay, so what I would like to keep on insisting is that I think that wind propulsion is here to stay, that IMO goals and decarbonization of the shipping industry will be achieved with a contribution of wind propulsion. I don't think that only with wind propulsion, but it's going to be an important part of that. And I think that this is a fact. And at bound4blue, we are ready to supply our systems to the industry as an efficient and economically viable solution to face these upcoming challenges of decarbonization. So what I would say to anyone interested is just make that first step. Contact us and we will do that business case for you at no cost so that you can see the benefits of wind propulsion on your fleet or on your vessel.
Excellent, and I think that hybrid message is so important as well. You know that this is it's a significant part of the problem or the part of the challenge, but it's not the only part of the challenge. And however, what I'd like to say today is thank you very much, David. You know, I really appreciate you joining us, and I'm really excited to see the further developments later this year and also going into 2022. It's going to be a huge year for you guys, I think.
It's going to be busy.
I can imagine. So, and to everybody watching this, you know, thank you for joining us. Listening to the Wind will be back in a short while with another one of the pioneers in the wind propulsion sector. I'd just like to say thank you very much. If you have any questions, you can always send those in to me or send them directly to David, of course. And just leaves me to say thank you very much and fair winds to all. Thank you, David.
You're welcome. Thank you, Gavin.